Hello, and welcome to the Artificial Podcast with your host, Nick Myers.
Artificial
intelligence, voice recognition,
machine learning,
robotics,
actionable analytics.
It is Nick's goal to help everyone understand the impact that emerging technologies are having on our lives both personally and within our organizations. Your glimpse into the growing world of emerging technology starts now.
Nick Myers.
Nick Myers. Nick Myers.
Nick Myers.
Hey there, artificial podcasters. Welcome back to another week and another episode of the Artificial Podcast. Nick Myers here, excited to present our second guest of 2021. I know it's been a while since we've had a guest on the show. Trust me, I've been trying. I've gotten a lot of notes and DMs from folks asking when you're going to start having guests on the show again, but I think you'll really like the guests that we'll have on the show today. And again, how did I meet today's guest? Well, he actually reached out to me via email, and I think Steve, who will be bringing on in just a couple of seconds here, is actually the first one to do that. But we have a really good episode, and I'm going to be welcoming Dr. Steve Shwartz to the Artificial Podcast in just a few seconds. We're going to be talking about the cold, hard facts of artificial intelligence. He is a veteran of AI research and the artificial intelligence industry as a whole. And we're just going to have such a cool chat. I can't wait. But before I beam Steve in, let me tell you a bit about Dr. Steve Shwartz. So Dr. Steve Shwartz is the author of Evil Robots, Killer Computers, and Other Myths, The Truth About AI and the Future of Humanity, which was published last month by Fast Company Press. He began his career in AI as a postdoctoral researcher in the Yale University Computer Science Department. Steve has also been a founder or co-founder of many companies. His AI-based Aspirant product became one of the leading business intelligence products of the 1990s. He also co-founded Device 42, which has won awards as a fast-growing tech company. Steve has also helped fund many startups, including Tango, which was the 6th best IPO of 2011. Steve, welcome to the Artificial Podcast. How are you?
Hey, thanks for having me, Nick. It's great to be here.
Yes, thank you for taking the time to hop on the show. And you have some shoes to fill, I will say. You're the second guest of the year. It's I don't know. No, last year I felt like we had a guest every other week, and then I was talking with our producer, and I'm like, you know what? Let's do more episodes of you and I and see where things go. And it was a lot of fun, but ultimately I'm ready to start having some neat guests like yourself back on the show. So I'm happy that you're number 2 of 2021.
That's great, Nick.
So I think, the goal of today's show is to dive into artificial intelligence, the cold hard facts of AI. So listeners of the Artificial Podcast definitely know that we have talked a lot about AI in the past, how AI is going to affect the future of work. I've had some other guests in the AI field on, and we start diving, of course, into the bright and shiny future that I think we all hope AI will present to us. But in your case, I'm excited to hear your perspective on really where we are at with AI and where it's going, given just your breadth of experience in this industry and your work. And of course, we'll touch on some of your book as well. So that's really what I'm hoping to focus on in this episode.
That sounds great.
So maybe let's kick things off here. So how or when did you know that you wanted AI to be your life's work? Because I've seldom come across people who have been in this industry for, well, I guess given, I'm only 26, so I don't have much experience to speak of, but, it's something I find when I meet people who are like, my entire career has been in artificial intelligence. So how did you know that you wanted AI to be your life's work and your career?
It's an interesting story. Well, interesting to me, at least. We'll see if it's interesting to the audience. I developed 2 interests during my undergrad and grad school days. One was statistics, and the other was what was then called AI, but it's actually very different from today's AI, and I'm sure we'll get into that.
Mm-hmm.
Back in the 70s, late 70s, at Towson University, I taught statistics techniques like classification and regression. They weren't called AI back then, but today, most of the amazing AI systems out there, including facial recognition and machine translation and speech recognition, use classification techniques, the same basic idea, but now they're based on deep learning, which enables more powerful computations. One of my first jobs was to use supervised learning to predict horse racing outcomes in 1979 for the top supplier of data to New York area bettors. And that was a
Really?
lot of fun. Yeah. And then when I was in graduate school, actually, that was while I was in graduate school, my graduate school advisor was Bert Green. Bert Green, in 1959, when he was at MIT, wrote the first natural language processing program. He wrote a program appropriately called Baseball that answered questions about the 1959 baseball season. And then I met Roger Schank, who had arguably the most important natural language processing lab of its time at Yale University, and ended up doing a postdoc at Yale and then helping Roger start an AI company in 1981.
So your experience, let me go back to, you said you worked on, you said it was supervised learning for horse racing.
Yeah.
So
Yes.
horse racing in terms of like betting on horses, or because that sounds interesting.
Exactly. So back in I think it was around 1979 or 1980, and really still today, professional sports bettors and serious sports bettors tend to buy data and analyses. And in 1980, in the New York area, New York, New Jersey area, the leading provider of horse racing data was Lenny Ragozin. And through, a friend of a friend, he heard about us and hired my partner and I to write a statistical classification actually it was a regression program that would take his data and predict the true odds of the different horses in a race. So then bettors would take that data and say, okay, the true odds are that this horse is 3-1 to win the race, but they're going off at 10-1, so that's a good deal for me, so I'm going to bet on that horse.
Yeah. So did anybody, I'm guessing people use that in the wild, right? Like people were using this actively to make bets, or was this more of just an experimental thing?
Oh, no. This was, people were actively using it to make bets, and it only lasted there was only an advantage for like a year or two, because pretty soon every provider of data was using similar regression techniques.
Yeah.
So it wasn't like we had, really invented anything ingenious.
We'll see, and that's kind of why I wanted to ask about that, because I think, and we may get into some of this, I still feel like there's this great mysticism around AI, right? You and I talked about this in our intro meeting, and I think it's just so cool and fascinating that a lot of what's common in 2021, you used to build something that could help people bet on horse races more effectively in the 70s using similar tech.
And actually it wasn't, this was just more of an experiment, but we took data from baseball, and we created a set of predictions that we published in the New York Post before the season. And we were able to predict 3 out of 4 of the playoff teams.
See? When you have AI, you don't need Back to the Future where you go and collect the sports book that gives you all the betting stuff. You can just use a model like you built to predict the outcome of a playoff series.
Yeah. And actually, believe it or not, today, even in today's world, when people use AI and they apply it to data, a lot of times you don't need the new deep learning techniques.
Yeah.
You can get away with the same linear regression techniques that we were using back then, and get a comparable result.
Yeah, and correct me if I'm wrong, but it's true that deep learning, or at least the concept of deep learning, has been around since the 60s, 70s, correct? It's been around for quite some time.
It's been around for quite
Yeah.
some time. Jeffrey Hinton was talking about it back in the 70s. In the early 80s, when we started that first company, we had a sister company that was commercializing neural networks.
Yeah, and this is what I try to communicate to people too. I go, as much as you're hearing about AI and the different facets of AI, machine learning, deep learning, neural networks, natural language processing, this stuff has been around for quite some time. It's just the computing power to actually make it better, I guess, or more efficient to actually use in regards to creating something that can yield a really solid result has just become better, right?
It's become better.
Yeah.
And to be fair, the use of neural networks has become a lot more accepted. It was kind of a fringe area in the early 80s.
Yeah. So with that, then, how much, given your breadth of experience in this industry, how much has the field or study of AI evolved throughout your career, and what stands out to you?
Yeah. So, when I was at Yale in the late 70s, early 80s, at Yale and pretty much at every other major academic institution, because we didn't have, back then, we didn't have, big commercial companies like Google and Microsoft doing AI. The focus was on building what's today is called artificial general intelligence, which is computers that can think and reason like people. Think the androids that you see in Westworld or Humans or HAL in 2001. That was our focus. We were trying to build artificial general intelligence, and it turned out in the 1980s we hyped it up quite a bit, and it was as hyped as it is today.
Yeah.
But it didn't pan out, so we never really got it to work. We realized it was way too hard. Funding dried up by the end of the 1980s. It was known as the second AI winter because a similar thing had happened in the late 1960s. There was a professor at Berkeley who said that in 1985 he had 500 students in his intro to AI class. In 1990 it was 25.
Oh my gosh.
Yeah. And then what happened, AI changed and started to focus more on a different form of AI that was more engineering focused.
Yeah.
To build systems that tried to do one small thing, like translate language or recognize faces or distinguish between a dog and a cat. And that's called narrow AI.
Mm-hmm.
And that's what today's AI is about. And that's been very successful, but it's very different. And there are only a few institutions that are even paying lip service to trying to build artificial general intelligence. There's OpenAI, and some of the academic researchers are talking about doing it,
but contrary to probably popular belief, it's not the large tech companies, right?
That's right. That's right. So yes, and everything that's been produced, that's so impressive, is narrow AI. There are systems that can only do one small thing. A system that can recognize faces can't distinguish between a dog and a cat, much less translate language.
Right.
A system that can recognize faces, knows nothing about humans. It doesn't know that
Right.
that people eat and sleep and argue and do podcasts.
Right. No, that's an extremely good point. I mean, we can even look back on some recent situations where that has stood true. Like I think it was just a couple of years ago, Amazon's facial recognition software called Recognition was it was proven to be biased in who it was identifying. Right. I think it was identifying African American females because the police were using it. I think, and it was profiling African American females more than anybody else. And
Right.
AI today, as I'm sure you can provide some more insight on, it's still only as good as the data you give it, right? I mean, if the data's biased, there's a chance the AI model will probably be biased.
Yeah, it's not just a chance; it almost certainly will be.
Yeah.
Yeah, and that's exactly what happened with the facial recognition systems. All the facial recognition systems to develop a narrow AI system, you basically feed it a large number of examples. So to develop facial recognition, you take a lot of images of people and their names being the answer you want the system to learn to compute. And what they did was they started with a large body of images of white males. So as a result, it didn't learn to recognize females and minorities as well as it did white males. And you would think at first blush, if you're using that system to recognize terrorists at the airport, you would think, well, that's a benefit to minorities because more minority and female terrorists will get through. But the other side of the coin is for the innocent citizens,
Right.
you're going to detain a lot more minorities
Yep.
and women, and that's just unacceptable.
Right.
That's discrimination.
Absolutely.
And it's not that anybody intends to do it. It's just that the data that you happen to use is just
Right.
not diverse.
Oh, and that brings up a whole, we could probably have a whole podcast episode on just ethical use of data, right? And how do we capture data ethically to the point that it's not biased? Because if you look at a lot of our historical data now, I mean, a lot of it is skewed racially, and that's just a societal thing, right? Which is unfortunate. So I'm constantly thinking about if we want to train AI models to be, to be completely neutral and not have a bias like humans do, we have to have unbiased data. But having unbiased data starts with changing society.
Yeah, absolutely. And there's Amazon ran into a problem. It built used AI to help it evaluate software developers to decide who they should hire.
I heard about that.
Yeah, but the problem was because historically they'd hired mostly males, the system ended up preferring males.
Of course.
And and Amazon wasn't biased. Once they figured it out, of
Right.
course they stopped using it. But it's just it's almost hard not to get biased data.
Yeah, I agree 100%. And a group that I'm involved with, the Open Voice Network, we're trying to produce standards for voice technology, but at the same time, it is being built from the ground up with the I guess the co-mission of how do we make voice technology and the data that powers voice technology inclusive for everybody. And that's a tall order. It really is.
That's
but it
really
needs to
hard.
happen. It needs to happen.
It does need to happen. And it's not
'cause-
just minorities. I mean, with voice, if you train it on Caucasians, then it's not going to be able to understand minorities as well.
Right.
But if you look at it as a global problem, if you only train it on English,
Right.
then how are the third world countries ever going to get out of the economic mire?
Exactly. Nope, that's an incredibly good point, and that's something I often think about too. And like I said, a lot of what plays into our current structure of data that we feed to our technology and these models comes from society, which is why the societal problems are intertwined with the tech problems. And it's like, the societal problem needs to be fixed, of course, more so, but that's the hardest one to fix, right? But then once that's done, it'll have a trickle-down effect, I would think, into hopefully having more data where we can train our models better without any type of unconscious bias embedded into them. So
Yeah.
hopefully we'll get there.
But I think one important point for the listeners, a lot of people think that that AI systems are biased because of unconscious biases on the part of the developers.
Mm-hmm.
And that's really not true. The algorithms themselves are, for the most part, going to be unbiased. It's just the data that happens to be biased.
Yeah, no, I've heard that too, and that's something that a lot of people, my understanding was even like, well, if you have a Caucasian male programmer who's developing this algorithm, then of course there's going to be some type of bias weaved into it. But to the very good point you made, I think it has to do more with the massive amounts of data the model is being fed or the algorithm is being fed versus the person actually just designing it, which I don't know. But I will. My hope is that we will get there, and we will. So we need to, if we're going to actually, and maybe we'll get into this later. If we can actually achieve an AGI, we're going to need to have unbiased data. Otherwise, the thing is going to break out and realize, oh, you humans are. What are you doing? Anyhow, so how much progress do you think we've made in the field of AI research since you started your work?
Well, we've made fabulous progress in narrow AI. I mean, facial recognition, machine translation, in your area, speech recognition. I mean, you could never smartphones could never understand the words you were saying or even hear the words, reproduce the words you were saying until we applied deep learning to them. And then all of a sudden we applied deep learning, and now you can talk to a smartphone and it transcribes the words you say very accurately.
I actually used the Google Translate app when I went to Thailand back in 2019 to communicate with taxi drivers and stuff. I could not believe how instant it was. And it was actually pretty accurate, too, according to the folks that I talked to there.
Yeah. And what's interesting about machine translation is that they didn't really start to use deep learning until I think it was 2019. So probably, and then overnight they switched from phrase-based machine translation into real deep learning, and the difference in translation quality was just huge.
Yeah.
So today you can go to a web page and click translate the web page, and it's usually a pretty good translation. I mean, I don't even. Yeah. It almost looks like it's native English.
Yep, I've done that in Chrome a ton of times, and it blows me away every time too.
But it blows me away. But 3 years ago, if you did that, you could kind of figure out what was being said on the web page.
Yeah. But
it was nowhere near. It was hard reading, and then they switched to deep learning, and all of a sudden, kaboom! It's just great translations.
Yeah, I would agree 100%. And you're not the first person too who's that I've talked to who's been a researcher in the industry for quite a long time. You said really the biggest advancement we've made is in deep learning and neural networks. And I think to the point you made earlier, because it's more accepted now, right? And I'm sure there's more computing power behind it that we probably didn't have back in the 60s and 70s.
Right. And I mean the progress in deep learning is just undeniable. It's affecting everybody in the world. Whereas the progress in AGI, getting back to the question you originally asked me, it's affecting nobody.
Right.
Because there's almost no progress.
Right. Well, and then I know we kind of talked about this where I think it was also in our intro meeting where I told you I really enjoyed Max Tegmark's book, Life 3.0. And maybe you recall from the beginning he talks about the Omega Project and how this small, tiny group of people created a super intelligent AI that just started running everything, literally. Yeah. Is anything like that being worked on? I'm totally kidding.
Yeah.
But that, when you think of AGI, right, it's this small group of people that nobody knows about at a university or somewhere, right? And it sounds like that's still the case, where a lot of the work in AGI is still more on the university and research front versus practical application and, commercial use in tech companies.
Right, but that's who we thought we were back in the 70s and 80s.
Yeah.
That's who Newell and Simon and thought they were in the 50s and 60s, and that's who OpenAI and parts of Google think they are today.
Yeah. So when we think about that, so I think a lot of people who are they hear the term AI, but they're of course unfamiliar with what AI actually is and what it can do. Maybe you can give a brief dive into we kind of talked about narrow AI, but what are some of the most common things that today's AI applications are capable of? And I think the big thing I'd love to hear your thoughts on here is, can today's AI, in air quotes, be classified as true artificial intelligence?
Sure. So most of what we see today in the world that impacts us in AI is either a result of supervised learning or natural language processing. So let me just talk about each very briefly. We talked about supervised learning a little bit. In supervised learning, you train a system on a set of data. So say you want to build a system that can diagnose a particular disease. You'd create a table of data in which each row represents one person. Half the rows represent people who had the disease and half don't. And the row for each person contains features from their medical record that are important, like age, whether the person smokes, and so on.
Yeah.
Then you take the table of data, you feed it into a machine learning algorithm that learns a function that can predict whether a person had the disease based on their medical record. And now once it learns that function, you can apply it to people who weren't in the original data set. And that's how facial recognition works. That's how machine translation, speech recognition, that's how they all work. And again, going back to Towson University in 1977, we used to call that statistical classification. Now, we didn't have the horsepower or the computational techniques like deep learning, to really do anything impressive like this, but it was the same thing. So that's supervised learning. So what you're doing is learning a function. That function to determine if somebody has a disease or to recognize a face. Those are simple those are mathematical functions, but there's no intelligence in those functions. They can only compute an answer to one question. What's the name of the person? Does the person have a disease, etc.?
Right. And it requires a lot of data in order to get it to the point it can produce that answer to that one question consistently.
Exactly. And then in natural language processing, the main impact that we see is in chatbots, Siri and Alexa and Google Assistant. And these actually go back to they all have an older stepsister named Eliza.
Yes, Eliza was on the tip of my tongue.
Eliza. So in 1966, an MIT researcher built Eliza, and he built Eliza to simulate a Rogerian psychotherapist. So a person would sit a person in a room with a teletype, and the person would type.
Yeah.
Men are all alike. And Eliza would answer back through the teletype. In what way? And they'd type in, they're all like my father. And Eliza would type back, what do you think of your father? And people would tell Eliza their deepest, darkest secrets. But the reality was, Eliza was a really simple program that just used patterns to recognize person's inputs and then took parts of those patterns and created the outputs. And that's not a lot different than what the personal assistants of today do.
Yeah.
They're all built with a set of intents, and developers identify all the different intents. And
Yeah.
those are, each intent is something a person can say to the personal assistant. And then the developer is also responsible for entering all the different ways that somebody can say that intent. And what's different today is that there are so many people working on these. So
Yeah.
if you look at Alexa,
Raise my hand included in that.
yeah, there you go. Yeah, you have a development kit, and you can create what they call a skill by packaging up 5 or 10 or 20 intents. And there have been people have created over 80,000 skills. It's practiced that 80,000 numbers from 2 years ago. It's probably 150,000 skills by now. So what's different between now and 1966 is the patterns that you can use are slightly more complex. And there are way more developers working on it.
Right.
But there's no intelligence in there's no real intelligence in these chatbots. They fool you just like Eliza fooled you.
Yep, and that's so before COVID, of course, I was doing a lot of speaking, and I called it my parlor trick. So because we develop, our CTO is really good at developing for Alexa and Google Assistant, and I would always bring one of my Alexa devices with me to the talk I was giving, and I would try and get a list of people who would be attending beforehand. And what I would do is, of course, we would program in, like, me having a conversation, like Alexa would always be like the sarcastic, persona in the talk I was giving, and I would have some back and forth, but then I would also have Alexa mention some of the names of the people in the audience. And Steve, if you could see these people's faces, you would think I was a wizard.
That is such a good idea.
Oh my gosh, they're how did you do that? How does it know? And oh my gosh, it got me every single time. But to your point, of course, us knowing the back end, we're still programming it to do things. It's not like, again, it's an all-knowing magical thing that it's not, right? There's still a lot of programming, and you have to create a path. But yeah, oh my god, I had such a blast doing that.
Yeah, no, that's a great gimmick.
But yeah, no, to your point, I think the biggest issue with voice technology now, and this, of course, is still a major piece of discussion in the industry, is that it lacks context. There's a couple of startups, like there's one I know called Behavioral Signals, and they're working on a semantics engine for voice assistants so they can hopefully start identifying extract semantic meaning from words. So, like, of course, how human beings understand emotional context behind words, maybe voice assistants can, but I think that's the biggest thing holding that piece of technology back.
Yeah.
It being AI powered is just, it can't understand context. And the question, will it be able to ever understand context, right?
Right, exactly. Yeah, and it's not, it's context, but it's also knowledge of the world. It's knowing that people sleep in a bed and have eyes and eat food and all those things.
Yeah, no, I agree 100%. No, that's really neat stuff, and I appreciate you kind of diving into some of those examples of what the current capabilities are, because again, I think it's still, to people who just, again, hear the word AI, they just automatically go to Hollywood movie animatronic robot versus, we're just running models to predict whether somebody is going to have a positive test for colon cancer or something, of the sort.
Exactly.
So maybe this is actually a good transition into maybe diving into your book that just got published. So Evil Robots, Killer Computers, and Other Myths. So I'm going to go on a limb and say you are demystifying AI in this book.
Absolutely. So in the book, I try to do three things. One is to explain in simple terms how AI works. And I want to do that so that people understand how it works. So then when I explain to them why today's AI systems can never evolve into AGI, they'll understand it. So that's the second thing I try to do, is explain why today's AI systems, supervised learning, reinforcement learning, natural language processing, can't evolve into AGI. And I left out unsupervised learning there because I think some academics would disagree with me if I said it can't. I personally don't believe it can, but I'm going to leave that out. And then thirdly, I talk in the book about what the real social problems are that we need to be concerned about. Discrimination and privacy, safety, jobs, and so on.
Fantastic. No, like I said, I'm excited to dive into because, again, I'm only in the understanding of a high level, right, from just the personal research and the books that I've read and how we've applied it in the capacity we have so far. But, I even recognize as I was first getting into AI, just out of complete curiosity, I still consider myself an optimist, but I think as I've been in it a bit longer now, I'm not as convinced as I may have once was that we'll have a super intelligent artificial intelligence or super intelligent machine running everything.
Yeah.
I mean, you just see, again, some of the problems like with Amazon's recognition and facial recognition and some of these chatbots that have proven, again, to what we were talking about earlier with biased data and how they interact. I just think there is a really long way to go. And with that long way to go, I don't know. And maybe that's something you can speak to. Like, do you ever think humanity will be capable of developing a true AI as we know intelligence in the form of human beings? Do you ever think we'll get there?
I really don't. And I'm pretty sure that, nothing we're working on today will get us there.
Yeah.
But, it's hard never to say never.
Right.
And I would say, to me, it's about as likely because we're also working on time travel,
right?
Reversing aging, teleportation,
traveling to Mars.
Traveling to Mars. Yeah, but I would say, to me, it's about as likely as time travel or teleportation or reversing aging.
Yeah, and which all I think are things that we want to have, right? But the question is, will they ever exist beyond Hollywood? And I often fall back on that. I let it go. Hollywood actually sometimes has this really keen way of predicting things before they happen. But when it comes to this type of stuff, I'm just... I'm always fluctuating back and forth between optimist and skeptic,
Yeah, exactly. I mean, you can never be 100% sure. A year or two before the first nuclear bomb, I forget who it was. I don't think it was Einstein, but a very famous scientist came out and said, it's impossible to split the atom.
Lo and behold.
It'll never happen.
And the next thing we know, we have weapons that everybody's constantly freaking out about now because it could kill us all. But no, to your point, never say never because, I mean, anything is possible. But I guess let's speak from the likelihood of it happening in our conversation. Do you think the likelihood of it happening, there's a high degree of likelihood that it could happen? And you don't think so?
I don't think so. And I think one of the reasons that I'm so confident is that, I've been part of working hard on trying to do it, and I know how hard it is. And I know, a lot of the ins and outs of the difficulties that would have to be overcome in order to produce such a system. And I just can't imagine ever doing it.
Yeah. Well, and I think about it too. I think about this all the time. We still don't even fully understand our own intelligence. We don't understand our own consciousness, right? Like, if we can't answer those questions about human consciousness and human intelligence and what makes that up, how can we ever hope to create something else that has the same thing?
Exactly. Exactly. I mean, I'll tell you a story. And sorry for all these stories.
No, please.
Back in 1980, I was part of one of the major academic debates in the AI community. And it was about how visual images are represented in the human brain. So I'll ask you this question, and I guess the audience should answer it also. What shape are a German Shepherd's ears? And now answer that question, and then tell me how you did it.
All right, so I said triangle, and the way I did it is I pictured what my last memory of seeing a German Shepherd was, and I see the pointy ears, and I see the face, and that's how I determined the shape was a triangle.
Right, and that's what most people report. So we created a theory. I mean, I was a minor part of it, but a Harvard professor named Steve Koslin, along with some others, on our side was you may have heard of Steven Pinker. He's written a lot of books. So we all say, visual images are stored in an analog fashion that you can search, much like a picture.
Yeah.
But then there was an equal number of researchers and some very famous people, one of whom was Jeffrey Hinton, who's considered the father of modern AI, who said, no, that's just, you're fooling yourself. What you have in your brain are more like a list of propositions or facts. In any case, I won't go into the whole argument, but there was a three-article series in Brain and Behavioral Sciences where 40 different research teams weighed in.
Yeah.
And some of the best brains in AI and other fields, we still don't know the answer to a simple question like that.
Well, then I think that's a testament to, again, if we can't figure out some of the basics of how we learn and how we learn, again, just what makes up consciousness, the process of, I mean, I read How to Create a Mind by Ray Kurzweil, and it was a fascinating book where he discussed his whole pattern recognition theory of learning, which I agree with, but I still felt like at the end of the book, it was a theory, and it still wasn't like, we don't even know if this is how it works,
Right.
Like, this is just another theory.
Right.
So, which he had tried to apply. Well, if we learn by recognizing patterns, then feasibly a machine could do the same thing. But there's the whole consciousness part of it, right? And taking the world around us and through our five senses and our brain constructing that into what we conceive as reality. Oh boy, I'm going off the deep end now. But you know what I mean? It's all of that, and it's like if we can't weave our way through the mud with that, how can we ever hope to create an intelligent machine like a human being?
Exactly. In my book, I have a chapter where I go through, I classify all the current ideas about how to get to AGI into 4 categories. And one of the categories is building a system that works like the human brain. But we've been trying to understand the human brain for 60, 70, 80 years, and we've barely scratched the surface. I mean,
right.
We've got to be hundreds, if not thousands, if not millions of years off from really understanding how the brain works.
Right.
And then
yep.
Once we do all of that, who says that we can copy it in a computer?
Right. No, that's exactly it. And that's often when I defer to the skeptic side of things, because I think about if we can't solve those fundamental problems or not solve those problems, but answer those fundamental questions, how can we ever hope to create a literal copy of human intelligence? And then even go as far to say, well, because it's a machine, it can even surpass human level intelligence and become super intelligent. And again, never say never, but I just feel like we have a really, really long way to go.
Yeah, I do too.
And it definitely won't be in either of our lifetimes, I don't think.
No, absolutely not. Absolutely not.
So, yeah, no, it's interesting to think about for sure. I guess, maybe let's say we don't ever develop a true AGI, but do you believe that narrow AI in the form that it's in now and the subsequent evolutions of that will ever be able to help solve some of humanity's biggest problems, say climate change, overpopulation, famine, food scarcity? Will it ever be able to help us solve any of those problems even if we don't achieve AGI?
Today's AI, narrow AI, is being used today to make minor contributions to all these problems. Microsoft has an AI model that can now predict severe storms.
Mm-hmm.
There are AI systems being used to improve crop yields. But the idea that, in 50 years from now, when we have a computer that's 1 billion times faster, we can walk up to it and say, how do we solve climate change? Kind of like Hitchhiker's Guide to the Galaxy.
Yeah. That's a good comparison.
I don't see that happening.
Yeah. Well, and I think if, even if it can't give us the ultimate answer to these problems, at least be a really useful tool in helping us work towards solving them. And I think that's what I'm looking for out of it more than anything, right? Is I feel like it can be a really solid tool to help us overcome some of these problems. I've always kind of viewed technology more as a tool as opposed to, at the end all be all of whatever a lot of people tend to think it is. I've always viewed it as a tool, and you can use a tool the right way or you can use a tool the wrong way. That's where my optimism comes in, where I hope we use the tool the right way and it'll continue to advance as we're using it the right way, so it does help us overcome some of these problems.
Well said. Well said. And I think that's exactly right. And I think it will be, absolutely will be used to help overcome these problems.
Yeah. So will the next billion or $1 trillion companies be AI companies? A question that I've also been thinking about.
Yeah, there's several private AI companies, Cloudera, Databricks, DataRobot, that are all doing $500,000 to $1 billion in revenues.
Yeah.
Or at least maybe I'm not sure if those numbers are right. But they'll all be major stars when they IPO. They'll all be unicorns.
Yeah.
So they'll at least be valued at $1 billion or more.
Gotcha. Because I've been thinking about that, and there's a lot of literature going on right now where it's what is going to be the next, or the next $1 trillion company, right? Or what's gonna surpass the Apples and the Microsofts and the Amazons of the world. And a lot of people seem to be betting on those being AI companies. But I'm also thinking of it too, and I'm like, well, maybe, but you also have to keep the AI company from being absorbed into the larger company that already exists, right?
Yeah, no, I just can't see any of these companies beating Google or Microsoft or Amazon or even Netflix, or Salesforce, or, but you know what, that kind of thing happens. You always have the leaders, and it looks like nobody can ever take them down, but eventually somebody does. Yep.
Right. No, that's I think that's a perfect answer to that question, and we've seen that time and time again. Well, as we kind of wind things down, I wanted to end on, this is the first time I'm doing this, I call it rapid fire questions. And what we're going to do is basically I'm going to go through a series of questions under the pretense of, do you think we'll have any of the following by 2050? And I'm just going to go through the list, and you can give yes, no, or maybe. Let me know when you're ready.
Let's do it.
All right. Number 1, all cars on public roadways will be self-driving.
Probably not. I guess that's a maybe.
Number 2, humanoid robot assistants. Think like iRobot from Will Smith.
Definitely not.
That's a shame. I was hoping you'd say yes to that one. I'd love that. Number 3, a real-world version of the Oasis from Ready Player One.
Definitely not.
Again, one that I was hoping you'd say yes, because that would be awesome.
We'd need teleportation.
Yeah, right. That's the thing. Teleportation or the Oasis, right? Number 4, AI that can develop full-length television shows and movies.
Definitely not.
Dang. AI that helps pilot inner solar system spacecraft.
That's a definite maybe.
I like that one because I was thinking, if we're supposed to be going to Mars and probably beyond at some point, there's going to have to be some computer intelligence in that, right?
Right.
And then the last one, an AI-powered virtual assistant similar to either HAL 9000 from 2001 or Jarvis from Iron Man.
Definitely not. I'd have to destroy all the copies of my book.
Dang. Well, I tried, right? I was like, which one of these I wonder would Steve actually say yes on? I tried. But again, let's go back to never say never, right? Who knows?
That's right. Absolutely.
No, that was fun. I like that. I'm going to incorporate that in other episodes. That
Good
was
idea. I like that too.
Well, Steve, thanks so much for taking the time to chat with me. This has been a blast, and it was really neat, again, talking to somebody like you who's worked on so many different and incredible things throughout the artificial intelligence space, and I'm sure just the people that you've gotten to meet over the years, and again, just seeing the evolution of your early work to now, I'm sure is just super fascinating. And of course, your new book too, which I highly encourage anybody listening or anybody watching to check out. It is called, again, The Truth About AI and the Future of Humanity, Evil Robots, Killer Computers, and Other Myths. And actually, before we go quick, I am going to do our first giveaway on the Artificial Podcast, and the giveaway will be a copy of Steve's book. So to participate, it's really simple. All you have to do is leave us a review on Apple Podcasts, and then take a screenshot of that and either send it to hello@theartificialpodcast with your first and last name in the email, or DM us on Twitter or Facebook with a screenshot of your review, and you'll be entered into a drawing for Steve's book, which I will be reading right along with you and cannot wait to dive into. Otherwise, Steve, this has been fantastic.
Hey, I really enjoyed the conversation, Nick. Thanks for having me on.
Yes, absolutely. And quickly before we go, I'll just reiterate a couple of things that I always do at the end of the show. Make sure to follow The Artificial Podcast on Facebook and Twitter at The Artificial P. Don't forget to smash that subscribe button on YouTube and click on the bell to get notifications of all of our new episodes. Visit us on the web at www.theartificialpodcast.com, where you can listen to all of our episodes if you so choose. Hopefully by the time I publish this episode, we'll have our Patreon set up with the Artificial Podcast Plus, so stay tuned for more details. And of course, you can join our Discord community by heading over to our website. That's a mouthful. Thanks for sitting through that, Steve.
My pleasure.
But thanks so much again, Steve. I'm looking forward to diving into your book, and thank you so much for sharing your insights, and we'll chat soon.
That sounds good, Nick.
Artificial
Intelligence. Voice recognition.
machine learning.
Robotic.
You've been listening to the Artificial Podcast with your host, Nick Myers.
Nick Myers.
To stay up to date with all of our latest episodes, you can subscribe on YouTube, Apple Podcasts, Spotify, Stitcher, and Google Podcasts. Or you can visit us on the web at www.theartificialpodcast.com. Until next time,